in English, so the guys that only know Portuguese, you can look at the slides. My name is Jaime Avezedo, and this is my introduction to Swift. Just a little bit of background. I work on this amazing company called Doist. You might have heard about Todoist, our most well-known product. Not the only one. And yeah, Swift. So Swift was introduced by Apple in June 2014, and their primary intention was to build software for their own platforms, iOS, macOS, whatever. And currently we are on version 2.3, but we are in an eye on 3.0. Preview 1 was out a couple of days ago, and yeah, it will be quite interesting in the future, and I'll show you later. So Apple says to us that Swift is a general-purpose programming language built using modern approach to safety, performance, and software design patterns. I won't talk much about performance because that's not really the purpose of an introduction. But I will talk to you about something that is really close to me, since I'm very distracted while developing, which is safety, and how this safety helps me do build better software, so software design patterns and stuff. So let's just take some myths out. What Swift is not. It's not a weekly type language, although sometimes if you already have looked into some code, it might seem like it is. It's not. It's not interpreted, so it's not like Python. You have to compile it. I saw a lot of guys talking about Swift being a functional programming language. It's not. Everybody was like, oh, we have maps and this and that. It's not. People also say that it's easier than Objective-C. This is very arguable. I won't go into it because there's no point. And it's not only for Apple platforms. So Swift was recently open sourced last year. And basically now Swift can be used, for instance, it was ported recently to Linux. So old versus new. So some things that are notoriously different. There's no need for a root class in Swift, so you don't need to inherit from NSObject anymore. Being NSObject the base class of Objective-C. Objective-C used messaging instead of dot notation. Messaging no more on Swift. Some people like, some people dislike it. One thing is for sure. Less square brackets, yay, and less, that symbol there. Yeah, semicolons. Yeah. Another thing that is really notoriously different is that on Objective-C you will have the interface file and the implementation file being the .h and .m, and now in Swift you only have the .swift file and everything is there. No more importing inside the same project. Swift uses namespaces, which means that you don't need to import classes that live in the same project anymore. And it's generally, and I think a lot of people agree with this, that it's simpler on simple tasks, which means that dealing with NS strings in Objective-C could be like a pain to do like a really, really simple thing, and Swift helps us a lot by giving simple interaction with a language to do simple stuff. Some new cool stuff for Objective-C developers. So this might not be new for you guys. You might have your language of preference, but for Objective-C developers, and right now a question: who's an Objective-C developer here? 1, 2, cool. And Swift developers? 2, okay. You might not learn anything new today, but sorry about that. Yeah, so mutability is not on the type. If you are, Objective-C had the mutable string, mutable array, mutable wherever, and that's when you tell to the compiler, this can change. And now it's set on the variable when you instantiate the variable, and not on the class type itself. One thing that again, it's really close to my heart is optionals. they are amazing for security, build safer code. Another thing that made our life much easier are generics, and that's not really new, but it's new for iOS developers at least. And value types and reference types have a major overhaul, at least on value types. So just to get things started, the difference now when setting a mutable or an immutable variable is on the keyword that precedes the variable. So when you set a let variable, it means that you can't change it. That's why you have an error there, and it's invalid, so you can't do anything besides its original value. And when you have a var, it basically means that you can change it and it can have other values. Another thing that you might notice here is that there are no types there. It's just because Swift is really, really good at inferring the types. So, it's a strongly typed language, but you don't really need when there's no need for that. Another thing that I want to talk with you about is optionals. And basically what means for non-iOS developer guys or non-Swift guys is that they are nullable. When Swift came out, their first premise was, everything must have a value. Otherwise, they have to be an optional. And, it's like some flags that you just have to write in order for you and the compiler to know that variable can be nil. And a nice thing that you need to know is that optionals work for every type. Let's start for the black sheep of optionals, which are the implicitly unwrapped optionals. In this case, we have a small example with a class being a person, and this person has two things. They have a name, which they definitely need to have a name, so after string there's nothing. And then people can be employed and unemployed, so company might as well be nil, because you might not be employed. So you are saying to the compiler, hey, this might be nil, and with the exclamation point, you are basically saying to the compiler, I know what I'm doing with this. So, when I want to address this property, well, just don't bother me, with anything else. When I address it, it just might work. It has to work. So, in this example, which is an example when implicitly unwrapped optionals are bad, is when you set this person object with a nil company. And, this exclamation point makes no need for any type of syntax when you want to address the company inside the person. So basically, this is just like Objective-C. When you try to address something that is nil, it will crash in runtime. So there's not a difference between this and Objective-C. But there are other options here that make things more safer. And implicit unwrapped optionals are basically a bad that we need to deal with, because there are two-stage creation of variables and stuff like that, so it has to exist. And if you guys are iOS developers and you work with nibs, that's precisely the case. You set something on on the visual editor, and the system doesn't know right away that it has to be an object, so it instantiates it as an implicit unwrapped optional. I went very deep here, and I don't want to, but let's go. Optionals. Optionals are much safer because, and the symbol tells it all. It's like, I'm not really sure what I'm doing with this. So this is like a warning sign. It's like, the other one was more of a warning that this is, but this is like, this might not have a value, so you need to be careful with this. And this is pretty good to, when addressing things, you need to explicitly, in this case, put the exclamation point, which is the operand that unwraps the value. And here you are strictly saying to the compiler, hey, I know that this might be nil, but I really want to see what's inside. And in this case, what it does is that it will crash again, because you are accessing a property that doesn't have a value, and it will be a runtime error. So I said that optionals are good, but they are not really, because they crash every time. So what did Swift bring? They brought something called optional binding. And optional binding is really my god every day. And I set the same example, company is nil, but here I'm saying to the compiler, if company is not nil, set it to this new variable that has the same name, company. And this variable, if company exists, will be set and will not be optional. Will be a variable that has a value. So inside the scope of this if, I don't need to unwrap or do anything, because I'm completely sure there's something inside of it. And this, this runs for much safer code, because you need to really think about if things, do all the cases. Like if it doesn't exist, I need to do something. Otherwise, I can't address it because it will crash. And this is pretty cool, because on Objective-C and previously on other languages, you have to check for nil every time, and it's really very, it generates very unreadable code, and it's a way of getting away with it. Another option is, and without checking if properties are nil, you have optional chaining. So let's imagine that you need to address a property that you are really unsure if it's nil or not, and you just want it to do something if it exists. Again, you just put the question mark there, saying that person exists, definitely exists, because I created here. And if company doesn't exist, don't run this. So it will not crash, and I don't have to check if company is nil. So it runs, I have, in Objective-C, I have here like last 4 or 5 lines of code. And this is pretty cool. And also a little bit, sometimes it can be weird, because it might hide some problems. Sometimes you might want company to not be nil, and it won't say, hey, there's a problem here, because I'm really nil and I didn't do anything, and you are not aware of that. Yeah. Away with optionals. We have generics now. And generics may be very familiar to you guys if you have done some work on C++ or Java. And they basically enable you to write flexible code. A lot of the standard library of Swift is written with generic code, which makes a lot of sense. One of the examples is generic collections like arrays and dictionaries. And generics basically means that you avoid duplication of some functions that have a defined purpose, and you don't need to create a function for every type available in your code, because they can be generic. And this is a nice example of it. Like swap 2 values. I don't care what class is T. It's like I just need to swap them. And this might not sound like a huge deal for iOS developers. This is a bliss. Okay, going away with generics, let's go to value types and reference types. And starting with value types, we have enumerations. I like enumerations a lot, just because I don't use them all the time, but they are really handy. And they are really a nice way of having, dealing with options in your code and dealing with small data storage that you need for each option. So, enumerations in Swift are just not like Objective-C. They are not like masked integers. They are just, their own type, their first-class types, and they can have no value. For instance, on developer type, you have Swift, Ruby, JavaScript, and Python. They have no value associated with them besides their own name. It's like Swift is Swift, and Ruby is not 1 or 0 or whatever. And another thing is that you can extend this or do another version of enumeration, which can have values attached to it. like you just need to make sure that if you want to attach a value like this on an enumeration, you need to make them all the same type, which is kind of cool. And if you don't want them to be of the same type, you can have associate values of any type. Just look at this example, connection status. You can be connected, or you can be failed. And failed is so generic. Like connecting, you know that you are connecting. Failed, or connected, you know that you are connected. But failed can be for a lot of reasons. And you can attach an NS error, which is like a foundation way of saying that there's something wrong, to this enumeration. So if the enumeration is failed, you know that inside of it, you can grab some information to help you while you're developing stuff. And also you can have properties, initializers, instance methods, and here's an example. You have developer type, and developer type can have a variable inside of it, like a computed variable. It can't store values, but it can have a computed variable saying like, developer type greeting, saying like, hi, I'm an iOS developer, or I am a Swift developer, or something. You can access properties and functions, and you can have initializers inside enumerations. Another value type is structs. Structs, have a major overhaul on Swift, and they are really, really powerful. Besides being a value type, which means that if you you create a struct and then you set it to another variable, it will pass the value. So if you change the second one, it won't affect the one that gave birth to it. So it's a value type. Swift is very optimized for this, and structs is a really nice way to convey information within your app without needing to use classes. And also, Swift is optimized to use structs in runtime, so you can use them like anytime they make sense to you. They also allow methods, define subscripts, initializers, just like a class. And one thing that structs can do is what I point here on class. So class is pretty much well known for everybody. And one thing that structs can't do is inheritance. So you can't have a struct that inherits from the other one. You can have typecasting, and you can have, but typecasting is basically because of inheritance, and you can have the initializers. And the initializers are very useful when you have major objects like view controllers on iOS, which are like the main, if you have a phone, it's like the whole screen, it can be a view controller, and they can be massive. And the initializers can be really useful when when you destroy that view controller, you just don't need to, you can destroy other properties too, because they are not needed, or do unbinding or anything like that. Protocols, another awesome stuff that you can do on Swift. They are just like Java interfaces. And, protocols, they were familiar to iOS developers because the delegate protocols were very used on Objective-C, and they still are. I try to go away from them, but, they are still used. And what are protocols? Protocols are basically a way of saying that any type of object or a type of object that you create has to conform to some rules, and the rules are stated in the protocol. Just saying that it has there, so I can show you later. But basically, protocols don't care if you have the properties are stored or not. You just need to set if the variable, the property inside the protocol is a gettable or settable or both. The only downside of protocols is that it makes like classes that conform to that protocol, all properties need to be vars, and it's a little bit of a turn down for me because let keyword is awesome. And this is a nice example. So imagine that you have a text box and you have 3 classes. that want to interact with that text box. And text box might say like, okay, so if you want to talk with me, if you want to deal with me, you just need to implement content data source. So I need to know when you are valid, when you have message content, and when you have recipients, and if you can upload files. So you don't need the classes that stick to these rules don't need to be inherited between them. runs on the screen through X time, it from a hidden state to a visible state through an alpha. And what this closure is actually doing is that it's a function, right? But it's actually capturing its whole container. So it's unknown self. It means that, okay, I have this fadeable view for me and I can work with it and things that it has. So inside that closure, I can do like self.alpha. So I'm accessing the fadeable view to change its alpha. And I'm actually also accessing its button to change its alpha too. And I won't go very deep into this, but there are 3 types of capturing values. You have the strong reference, the weak reference, and the new unknown reference. This just means that, this is a weak reference to self. Otherwise, it could introduce like retaining cycles and stuff. But I'm pretty sure that self will exist, okay? It might not be true, but unknown just means that I'm pretty sure that self exists and, I can just do these changes here. Another example of closures are closures within, the standard library. You can have like a sort or map or reduce or filter. And one of the things that Swift is enforcing is the syntax, cleaning up of the syntax on very simple examples. So I'm unsure if you guys can see this well, but this rev, so we have an array of names, and this is rev, okay? Rev does one thing. It makes the names by alphabetical order. And rev2 does pretty much the same thing as rev1, and rev3, and rev4, and rev5, and rev6. So they all do the same stuff. But, Swift gives you so much, cleanup of things that are, visually confusing that you can just, make it as simple as possible. So what does this do? The sort gets a closure, and you provide the closure to the sort, saying that, the closure gives you, or the sort gives you 2 strings to work with, and you provide a boolean to the sort. So your closure provides a boolean to the sort function. And yeah, so S1, if it's bigger than S2, returns true, otherwise it returns false. And this is the way that you sort internally this string of names. But you actually know that you need two strings, so you don't really need to, because it infers the type. So it really knows that it's working with an array of strings. But I haven't said that this was an array of strings, but it knows. And so I don't really need to tell, or nobody needs to know that this is strings because they are really strings. And and I know that these 2 strings are inside the closure, so I can return this. But the whole purpose of this closure is to return something. So why would I need the return keyword? It doesn't make sense. So then again, I get two things to work with, and I work with them. And the result of this expression is the return value, and the compiler knows it, and whoever reads this and is familiar with Swift will know that. Also, closures introduce wildcards. This means that instead of S1 and S2, I have like the first position of the array, or the array that internally sort has, and the second position. And I want to compare those. So just compare it like that. This rev5, and I need to stress this out, is the most used form that I work with, because not every case is as simple as putting a greater than symbol, and the compiler knows and everything knows. Because you can work with maps and reduces and filters and transforms, and these comparisons are not that simple. They might be simple, like in one-liner, but they are not that simple. But normally I use the wildcards to do something. If you want to do a map and address do all of these names into uppercase, you will do just $0.2 uppercase string, and the result would be an array with all strings in uppercase. And basically, these functions are the reason why everybody was like, "Oh, Swift is functional," blah blah blah. It doesn't make sense, but they came from functional programming. They are there. They are super cool. I use it every time, but doesn't make Swift functional. What does make Swift functional is function. Not really, but we have functions in Swift, and functions are a special type of closure. They are a named closure. They can't really capture from the outside, because they have a name. So you either choose your power, and they can have a pretty cool thing that they have is default parameter values, and they can also define external and internal names. What does this mean? So, coming from Cocoa and Objective-C, I'm not really used to do like documentation, and people that work on iOS generally are not doing a lot of documentation on their methods and functions, because generally the names of the functions are just like this: greet person name with greeting, and talk about weather. It's like they are very, very descriptive. But there's a problem with all of these descriptions, is that using a variable name called with greeting is not really nice. It will make you want the signature to be verbose, but you don't want the code inside of the signature to be verbose. So you can set internal names, like on this example, greeting. And I know that when you access this function, you won't see greeting, but me that implements greeting, I know there's a variable called that basically infers a string that has a greeting. And there's another example. You can also use functions if you like to without this internal parameter. So we have two examples here. Here is the first example with an external and internal, and here is the external that also becomes the internal because there's no internal. Another thing is that you can set default parameter values. So I can call this function, and I'm sure that this is very close to your heart in Objective-C if you have done some frameworks or libraries, because you often gave a lot of options to construct an object that sometimes the parameters could have default values or nil values, and you would often create 5 or 6 signatures and then point all of them to the method that would implement it anyways. In this example, you have all of them in one. So you can call this function like greet person name. And we already know what greeting can be, and we already know what about weather can be. So I can just call greet person with name. Or I can just call greet person name and talk about weather. And the greeting will be a hello. Or I can just do the 3 of them, okay? So I have a lot of functions defined here, and I can just use them wherever I feel like to, and it's useful and also ends with less code. And the function, if talks about weather, say something, otherwise say otherwise. Functions, they're pretty powerful. And this is another example why people say that this can be functional. It's because they can take functions as parameters, and they can return functions and as return types. And a function can be a type by itself. So you can have like a completion block that can be a function, and it's a type. It's a int, something that has a parameter of int, and something that returns a bool. So this is a type, okay? And we have a variable of this type that is a completion block. Another thing that is, I haven't used it in my life, but it seems that it's possible. It's define functions inside functions with like named functions. So you can have like function A, and inside define function B that takes parameters, and then function C that takes parameters. And those functions will work as closures, so they can get the variables that are on the parent function, but not on the whole scope, just like closures. So basically, you can't capture self. Actually, you can. Patterns. Another cool thing, and this is more of a syntax sugar, and it helps a lot, is there are many types of patterns in pattern matching in Swift, and I just wanted to show you three here because they are pretty much the ones that I use most, and you guys might look at it as useful. We have the wildcard pattern, and this means that, on this example, we have an array of tuples. So you can have tuples on Swift, and you can return tuples if you want. And and I'm not really interested in the first part of the tuple. And instead of passing it to an array or do something with it, I just say to the compiler underscore. I don't care what goes here. I really don't care. I don't want it for anything. Don't even instantiate a variable for it. I just don't care. I just want the second value. And it turns out there's another pattern or another keyword, which is the where variable. And on this precise case, I just want to use the second value of the tuples. I'm looping through them, and I'm just grabbing the tuples that the second value of the tuple that has the second value of the tuple greater than 5. So this basically means that I will only work with 6 and 8 because the other ones I don't care. And this is called the tuple pattern. Then we have typecasting pattern, and this is more, this is really more a real life situation and much more useful, where you can, have a function that takes any object and deals with it in its own way. So you can have the typecasting pattern, which is basically this let string as any type, or let variable as the type that you want. So what this function actually does is you take any object there and you want to return a string based on the value of it. So you go through a switch and you just work against strings, ints, and person. So you are only interested here in this case on ints, strings, and persons. And any other kind of object, you just return empty or nothing. And what this means is that if this case, so if the object, any object, is a string, is of type string, I want to instantiate a variable with this. And now inside this scope, everything or a string is really a string. So I can do all sorts of things with strings, and in this case, I just want to return a string. The same goes for integer, and the same goes for your own types that you create on your program. Okay, so far so good. A lot of theory and technical stuff, and Swift in real life. I know that I passed the 30 minutes, but 5 slides more. Swift in real life. Okay, so this is my personal opinion on this. I know that we have some discussion time, so this is where I want to discuss afterwards with you, because I really have my own opinion, but who cares about my opinion? Swift in real life. Tools are much better, even though talking with Fabio some minutes ago, we can't even find an refactor like on the whole project. We still can't do it. So tools are better, Xcode is better. That's why I use anyways. In the beginning it crashed all the time. I haven't crashed as Xcode for the past maybe a month or something. So maybe I'm not working enough, I don't know. But the only problem I see nowadays is syntax highlighting. It sucks. Auto-completion definitely sucks. If I do a small mistake I'm going there. You write something and then you keep writing and you don't really want to fix the problem that you inserted before because you know that it's there. You just don't really want to go there, but then syntax highlighting doesn't work for the rest of the code that you are working, and it's a mess. But 1 year ago it was even worse. Combining Swift and Objective-C can be tricky, and I will talk about it later. And one thing that Swift introduced was playground. So Xcode has this thing, and now iOS will have in the next version, which is called Swift Playgrounds. And Swift Playgrounds are a really nice way, not only as the name says, it's not only for kids playing with code and learning Swift, or people learning Swift in general, which is a great tool, by the way, to use it and to learn Swift. But it's also really great because it supports Markdown. So you can really, dump all your algorithms there and write some Markdown and explain why you did that, and share codes with your friends in your company, and do wherever you like to. And yeah, and migrating versions can be a pain. I'm looking at you really 3.0 because they are really introducing a lot of stuff, really new stuff that it's going to break a lot. And they even say to you like, hey guys, we are doing this amazing migration tool, and bollocks, doesn't work. So yeah, until now, it was a really pain. It will still be a pain on 3.0, but Chris Ladner, the creator of this beast here, said that they will take into consideration dependencies on the next versions, so we don't really have to break everything on our code base to deal with that. But I'll talk about it later. Swift and Objective-C. As I say here, interoperability will do a whole new talk. It's like a beast. I would advise, in real world you have to use it, but I would advise, stay away from it. But if you have to, but it turns out that, using Objective-C in Swift is not that hard. Doing the other way around, it might be a problem. Because Swift implements a lot of stuff that Objective-C doesn't, and making Objective-C understand what Swift is offering on its APIs can be tricky. You have to do some kind of conversions and stuff. So it's a whole new mess. I would advise you not to do that. Okay, and a little bit about talking the future, and this is my last slide. Thankfully. Yeah, so Chris Ladner told us that they will be more aware of dependencies. So after version 3.0, as you know, or I might have not told you, Swift is an open source project. It went open source last year, and currently you can do your pull requests for feature requests or fixes that you want to be seeing on the next versions. But until recently, nobody really non-cared if the changes would break the current code, and that made for a really non-reliable production code, because you have your code, it's super awesome, working amazingly, and then suddenly the migration tool doesn't work, and you have to refactor something, and then you introduce the bug, and you are, and that really is bad. So after 3.0, each proposal of change in Swift will be having a new chapter saying, what is this going to break? I'm really sure that I can do anything else to make things break less, or I'm really sure that this won't break anything. Okay, and that's when things get accepted or declined to be really shipped on the next Swift version. Also, Swift 3.0. Okay, so these are some small changes. I have seen a lot of talks about this. You will feel the pain. I can't really stress enough things here. So you go home and fix your code to Swift 3.0, because you will again find a lot of problems. So anything that I say here to you will be useless besides this, which is Objective-C legacy syntax will be reduced. So for instance, methods and properties that would have like huge names and redundant names that was very, very traditional of Objective-C will be chopped off. For a nice example would be UI color, which is a UIKit way of defining colors. if you wanted to have a green color, the default green color, you would use UIColor.greenColor. Now you will only use UIColor.green, and this will you will have to refactor this, otherwise it won't work because it doesn't know what it is. In a more high level of things, or lower level, depend on your perspective, GCD, so Grand Central Dispatch, will be, so I'm talking about queues here, okay, and multi-threading. In Swift it was a mess. It was still with the same syntax of Objective-C with some changes that made things even worse. And now, queues are objects, or at least you can look at them as objects, and you can work with them as objects, and you can do stuff. You can access properties and function and methods and whatever. So it's good. Another thing that is going to change is the first parameter labels. So I can come here and tell you that in Swift 3.0, this function would be greet person name with greeting talk about the weather. So generally, and this is not a really good example because actually it is. This person would be there between in the name. So you can have external parameters on the first parameter, which wasn't true in the past, and now it's going to be. Okay. Nevertheless, this is like small stuff. And yeah, Core Graphics APIs will have a Swift overhaul, and unsafe pointers are now optional, so you can check for their nullability because they might be, and normally they are optional. There will be a lot of other Swift projects. Swift was migrated to Linux recently, so I'm pretty sure that Linux guys will do a lot of stuff. And yeah, this is not really a good or a bad thing. It's just saying that Swift is very dependent on foundation frameworks. It doesn't implement like a lot of NS-string stuff because NS-string is from foundation, or it doesn't implement like regular expression because regular expression is from foundation. But Objective-C was the same because so Swift without foundation is basically zero. So, or you can do a lot with it. And that's great because, and as I told people previously on before the beginning of the talk, and just finishing, it was easy to migrate from Objective-C to Swift because the majority of things kept the same, which is foundation. Sorry about this, a lot of technical stuff, but I hope you guys have some questions. And yeah. Yeah.
You mentioned the optional chaining, I believe.
Yeah.
It's been a while, right? If I remember, that was the default behavior in Objective-C, right? The message passing. If you have the nil, it would just ignore the.
No, it would crash.
It would crash?
Yes.
Okay.
Access something that doesn't exist will crash.
It would crash if you sent a message to him.
Oh yeah, that's true.
But you have a way to catch the exception that will be triggered there?
It won't.
It won't trigger nothing.
Yeah.
So it's hard.
Yeah, it just doesn't do anything because the companies know.
Yeah. That's dangerous.
That's what I said. What can happen is that this might not work as expected because you might expect company to have a value, but it might not have, and it won't crash. So you don't really know that company is not there. It just doesn't work. And then for some reason in the future, you see that something that should have happened didn't happen, and then you have to trace back all the way to this and see, why company doesn't have a value. But anyways, for syntax,
It's amazing.
yeah.
I have a question. Can you go back to the greet person slide?
I don't know where greet person is. Okay. Greet person. Do you have any idea what? But these are the last ones.
With greeting.
No exemplos dos nossos.
It's functions. It's functions. Okay. Protocols, extensions. What's going on? Functions.
Yes, that one. Does the order of the arguments matter, like in Objective-C?
Yes.
Okay.
So if you can't, even though these two are set,
Mm-hmm.
you can't do like greet person name, talk about weather with greeting.
Okay.
You need to do it on the, by the order. So you can do with greeting, talk about weather.
Thanks.
The first name is used when you invoke the function, right?
The first name.
With greeting is used when you invoke the function.
Yes. So when you invoke the function, you would write something like object dot greet person, then you would have a string, then comma with greeting, colon the greeting, and then talk about the weather and the value.
And you can leave the with greeting out and you use
Inside the function, when you implement the function.
So
Sorry.
when you call, you can leave out with greeting because it has a default value.
You can not use. You can.
But if you use it, you have to put in the correct order.
Yes. If the completion thing on Xcode works really well, it would be easy to use this. But it's really not very useful because if the syntax completion doesn't work really well, you are really unsure about how the API is, and it can, But it's a very practical 10-second problem. They all pile up.
The syntax that you've been using, it's not 3.0 yet.
It's not. It's not. Yes. I have a reason for that. I haven't worked a lot with Objective-C, and that shows with the question that you did. But the thing is that I got Objective-C in a really late stage. That made me not understand like the basics and where it came from. So I really like to be on the edge of the state of the art of things. But when explaining something, it's better to really go a little bit back to make people understand why it came from there. That's my reasoning. That's why I didn't do anything on Swift 3 because the changes are not that big, actually. They will break everything, but the changes are not that big.
I have a question. Can you go back to the closure, the first slide for closures?
Yep.
That first one you passed?
Yeah.
Or the second one, where you have that unknown itself?
Yeah.
Can you explain that again?
Yes, I
It doesn't
can.
make any sense.
Yeah, it's so you can't. I haven't really tried this, but you can write self.alpha without unknown self, but I think it will be a compile time error. And the reason for this is that you are in another scope. So you are inside the closure, but you are really not inside the class fadeable view.
Okay, so let me just step back. That fitting, is that a method or is it just a function?
It's a method, but this is a method or a function, whatever you want to call it.
No, I mean,
But
it's a
the
method.
closure is this only.
Oh.
The innermost.
Okay.
Yeah, the innermost.
Stations.
Yeah. So closure.
So you have to specify what you want to close over.
Yeah, what I want to capture to be using inside the closure. Yes, because this might be run, on another thread or any other thing, and you need to capture the value of the class itself so you can change its values. Because this is another scope. This won't run like in synchronously.
So whenever you have a closure, you have to specify what you want to close over.
Yes.
That's new.
Yeah, and that's one of the at least my co-working friend. That's what we call each other, or programming friend. we are nice fans of this, but we found a problem with this, is that you can't trace back who is self when you go to so we have another way of writing this. Every time I write unknown self, I don't write an unknown self. I write unknown a self equals self, so the variable knows what it's referring to. Okay, but this is an intricacy of Swift. It's like, it's for the compiler to know that this variable is that object, because saying self is very abstract. And a self is kind of a pointer to that object, and I
think JavaScript developers
will understand this. Yeah, and basically, just to finish. So basically what's happening here is that you capture this. This might run in another thread asynchronously, and you just need self to be alive. And this unknown is like the easiest version. It's like, okay, I'm pretty sure that self exists. So it's as I said, it's a weak reference. So you don't capture values. They might run into, capturing, basically you're creating a zombie. So that's why you use the unknown. But the unknown means that it's not a weak, because weak can die, and you really need to be aware that weak can die. But unknown is like, hey compiler, I'm pretty sure that this will be alive by the time I want to use it, although this is a weak reference. Okay, it's a new type that Swift added, I guess.
We don't have any more time for questions today, but we can discuss afterwards. So let's thank Jaime for his presentation.
Thank you guys.